Okay, let's have a look at acyl chlorides, otherwise known as acid chlorides. You can call them either acyl chlorides or acid chlorides. The general formula, actually, let's just take a look at one first. Ignore the polarity indicators for now. So basically, an acid chloride has a COCl functional group. So it has the carbon group plus a Cl. So it makes it an acid chloride. So it's very similar to a carboxylic acid, except that instead of an OH here we have a Cl. Okay, the functional group is terminal, which means it takes place at the end of the molecule. The naming is something ennoyl chloride, methanol chloride, ethanol chloride, propanol chloride, and so on. The first carbon, the numbering of the carbons always begins from the end with the functional group, with the acid chloride functional group. So that's the first carbon, the one that has the O and the Cl attached to it. Okay, they are polar molecules, but they do not have hydrogen bonding, as a result of which their melting and boiling points are relatively low. The smaller chain acid chlorides are colorless liquids with pungent odors. They are highly reactive, and that's important to keep in mind. What the reason for that is that we have a carbon attached to two highly electronegative atoms, the O and the Cl. And what this means is that we end up with this becoming quite a positive region. Okay, the electrons are pulled away. The electrons in these bonds, these shared electrons that are forming the covalent bond between the atoms, are drawn away from the carbon, leaving an exposed positive region here. And what we see here is that C is very susceptible to nucleophilic attack. Now that's a big word. Nucleophilic. What a nucleophile is a nucleus-loving substance, or molecule rather. Sorry. So a nucleus-loving molecule is one that has somewhere on itself it has a negative charge, maybe some unbonded electrons. So that's why we use this little minus to indicate that it's a negative. The molecule has a negative region somewhere on it, and therefore is attracted to, in this case, the positive carbon. So what happens is, show in the next slide. So we have another molecule that has a negative region, which is attracted to this carbon and bonds with the carbon, replacing the Cl. That's what nucleophilic attack is referring to here. A nucleophile is another molecule is attracted to this carbon nucleus and forms a bond with it, replacing or displacing the chlorine. So, yeah, acid chlorides are highly reactive. They react vigorously with water, and they'll even react with moisture in the air. Okay, we're going to look at these reactions: preparation, hydrolysis, condensation with alcohols to form esters, and formation of amides. A side note, hydrochloride gas is always formed in acid chloride reactions. So firstly, preparation. How do we make an acid chloride? We take a carboxylic acid and we react with a chlorinating agent such as thionyl chloride, or phosphorus pentachloride, or phosphorus trichloride, PCl3 or PCl5. And we get a substitution reaction where the OH from the carboxylic acid is replaced with a Cl, and we get our acid chloride. The byproducts are not so important as the organic product. Hydrolysis, reaction with water. As I said before, acid chlorides react vigorously with water, and this is to go back from an acid chloride to a carboxylic acid. So we get a substitution reaction where the Cl is replaced with the OH from the water, and we go back to a carboxylic acid with HCl as a side product. Condensation: if we react an acid chloride with an alcohol, we get an ester. The oxygen from the alcohol bonds with the carbon from the acid chloride, and we end up with an ester. For example, if we took propanol chloride and methanol, we end up getting methyl propanoate. So whatever this acid chloride is, that forms the carboxylate section of the ester. So in this case, we had propanoyl, so we get propanoate. So this is our propanoate here, and then we've got, propanoate is here. Make a mistake, propanoate is here, and then we've got methyl from the alcohol, methanol. So we get our, whatever our acid chloride is becomes the carboxylate section of the ester, and the other part, in this case methyl, comes from the alcohol. Okay, to form an amide, in this case we're just reacting with straight ammonia in alcoholic conditions. So we take an acid chloride, we react with ammonia, and we get HCl as a byproduct, and the NH2 joins the acid chloride to form an amide. In this case, this is a primary amide. If we reacted with an amine, such as like a primary amine or a secondary amine, then we'd get a secondary or tertiary amide, something a bit more complex than this. This is just a very simple amide, in this case ethanamide. So if we took ethanol chloride and reacted with ammonia, we would get ethanamide. Okay, and that's acid chlorides.